Flack math! Give me some math and I'll give you some flack. Flack math!
Advanced factoring, lesson 61. Okay. So factoring is already exciting and awesome, but now we're going to do advanced factoring. So far we've been talking about factoring quadratics, so our factoring so far has really stopped at a degree of 2, right? Unless we can like take an x out of all of it, and then we've got, like maybe we started with an x cubed, but everything had x's in it, so we could take it out. But right now, we're going to step it up a notch, or step it up a degree here, okay? So let me just start with this factor theorem. Here's what the factor theorem says. Chaotic. So for polynomial p of x x minus a is a factor of p of x if and only if. So this little symbol, can one of you guys do me a favor? Can I get like 2 markers? Like I need more black markers. From the, yeah, they'll give it to the hobbit hole type of thing. They're in the hobbit hole, but can you just ask? Yeah, or you can just go to the front desk and say, Mr. Flack is wondering if he can have a couple black markers. Thank you. So this IFF is just a symbol for if and only if. If you guys are in geometry, you know that if and only if means that it's reversible. So like the then statement and the if statement can be reversed, okay? So if and only if P of A equals 0. So when you plug in A, when you plug in 0 for A, then you get, no, if you plug in, not 0, if you plug in A, whatever A is for the polynomial, it's going to give you 0, okay? So like when we factored this, we had like x squared plus 7x plus 12. So when you factor it, like if you set it to 0, this is x plus 4, x plus 3 equals 0. So x equals -4 and -3. So when you plug in that -4 and -3, it gives you 0. Okay, so that's only what that says. All right, so don't overcomplicate it. Usually when I have you write out theorems, it only matters when we start doing examples, okay? So you won't be tested on this or anything like that. But here's what that means. Let's say x plus 2 is a factor. X plus 2 is a factor of x squared plus 10x plus 16. Well, according to this theorem, if I plug in -2, I should get 0. Do I? Well, let's check it out. So we get -2 squared is 4, and then -20. So 4 -20 is -16 plus 16 equals 0. Yes, it is. If I were to factor this, it would be x plus 8, x plus 2, right? And so what makes that 0? Well, these are the factors. Those are the factors. And that's what makes that 0, basically. Okay, so let's do this. So to determine whether a linear binomial is a factor. So here's example 1A. Thank you very much.
Yeah, of course.
3. Huh. Wow. We'll see if this warms up a little bit. Okay, so here's what A is. So we're going to determine whether linear binomial is a factor of the polynomial. Here's P of X. P of X is 2x to the third minus x squared minus 43x plus 60. Okay, so I want to know if x, I keep losing my place, is x minus 4 a factor? Okay, all you have to do is plug it in. So you can plug in 4 there. Okay. Another way to think about this is synthetic division, because really synthetic division is just plugging this in. If I use synthetic division, the 4 goes out here. I put my coefficients there. Okay, and then just do synthetic division. Bring that down, multiply by 4, add, multiply by 4, add, multiply by 4, add, and you get 0 remainder, which means it is x minus 4 goes into, it's a factor of 2x cubed minus x squared minus 43x plus 60. Okay, I could have plugged in 4 here, and I would have got 2 times 64, which is 128, minus 16, which is something, minus 43 times 4, which is another big number, plus 60, and it would have come back to 0. That's fine. But in this case, I think synthetic division was easier. Okay, so you can either plug in 4 to see if you get 0. Okay, or you can use synthetic division and then divide. So you remember in synthetic division, you're just dividing this by that. So change the sign of that, put it on the outside, write the coefficients, and follow the steps of synthetic division. Okay, let's try another one. See if you guys can do this on your own. And I'm going to start giving Flack attack coupons for this. So remember, when you build up 5, you get a free problem set. So if you get this one right, I'm going to give you Flack attack. Not a free problem set, but one towards the Flack attack. And Silas, if you're listening, you can text your answer, okay? So I want to know if x plus 3 is a factor of this. Let's see, of P of X, which is x cubed plus x squared minus 24x plus 36. So is x plus 3 a factor of x cubed plus x squared minus 24x plus 36? So I would recommend using synthetic division, but you don't have to. I mean, you can just plug in -3 and see if you get 0. Okay, who's got something to show me? Yeah, you can just stop there. So if you have anything over here, right. So Allison, let me know when you're done and just give me a yes or no. It's a factor or it's not a factor. What'd you get? Yes or no? Is it a factor or not a factor? Like at the end there?
Yeah.
Yeah, so if you get anything and you don't get zero, then it's not a factor. Yeah, so because a factor will go in evenly, you know, and there won't be a remainder. Okay. So let's see, then blah, 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 54. What is that? 90. So you guys did the math wrong, but you lucked out. Okay. Because it's just a yes or no question, right? So it's not a factor because you've got, if you end up with any number except zero there, then it's not a factor. Okay. All right, let me update. You had 80 or 90 or 80 or whatever?
Well, I didn't
90.
write the number 90 there.
Oh, okay. Good
Should
job.
stop there.
Yeah, so really, yeah, so you're just like, it makes it easier because then you don't have to do exact math, I guess.
Right. Yeah. I know.
Especially on that last one. Okay, so let's move on here. So this is helpful because we can try to determine right away if something is a factor, and if it is, then you can factor it out. So that's part of factoring. If you factor out something like that, then that makes the exponent go down. So that means if you can get it to a quadratic polynomial, then you can factor it using our 3 steps of factoring quadratics. Look for a greatest common factor. Oh, you should have already done that. And then look for a difference of 2 squares. And then finally the trinomials. Okay. All right, so here's the deal. Here's some shortcuts. If you're ever given something like this, so you should write this down. This is sum and difference of cubes. So sum of cubes. So not like a difference of 2 squares. This is the same kind of concept, but now we're talking about cubes. So the sum of 2 cubes. For example, a cubed plus b cubed. This is how you factor it. A plus b, and then inside is a squared minus ab plus b squared. Okay, now if I wanted to do a difference of 2 cubes, so in other words, a cubed minus b cubed, it looks like this. A plus b, or a minus b on the outside. And then you've got an a squared plus ab plus b squared. So the only difference of these 2 things, and we're going to do some examples not with a and b, but with actual cubes. The only difference is this sign right here and this sign right here. So this is going to be the same, and this is going to be the opposite. Okay. So if I were to distribute this, multiply all that out, you would get this, right? Because things would cancel, and you'd be left with a cubed minus b cubed. If I were to multiply all this out, then you would get that. Okay? All right, pay attention, please. Put that phone away.
Oh, I'm writing that down on my notes because I don't have paper right now.
You should borrow some paper. Okay, so let's try a real life example of the sum of two cubes. Here's example 2a. So all we need to do is replace a's and b's with these things. Well, the first example is d to the third plus 125. Now these are two cubes, right? Cubes are things you can take the cube root of. You can take the cube root of d cubed, it's d, right? You can take the cube root of 125, it's 5. So if it's easier, you could write it like this, d cubed plus 5 cubed. Okay, so now a is d and b is 5. So we're just going to replace it. So this is a sum. So we're going to say a d plus 5, right? So we're just replacing d with a and 5 with b. And you get d squared minus 5d plus 25. So this is just multiplying a and b together. So whatever that you end up with, d and 5, multiplied together, 5d. And this is just this number squared. So if I wrote it out like this, I could do d plus 5 if you wanted to. D squared minus 5d plus 5 squared. I just replaced the a's with d's and the b's with 5. Now you can always check this to make sure it's right by multiplying it out. D cubed, negative 5d squared, positive 5d squared cancels. 25d, and then 25d, where is it? 25d, and then what do we do here? One of those, yeah, negative 25d cancel, and then you're just left with that 125. Okay, that's 2a. Let's try this one on your own. So here's 2b, 27 x to the 6th plus y to the 9th. So I would recommend writing it like this with just a cube there. So use parentheses and see if you can get there. So this might be difficult, but you can try it, and if not, we can just do it together. So we just want to factor this. So the whole point of this is trying to factor polynomials that have an exponent greater than 2. And this is something you should recognize. Okay, this is a sum of 2 cubes, because x to the 6th, or any multiple of 3 exponent, is a cube. And 27 is a cube. Cube root is 3. So if I were to do this, you can keep working. Let me know if you get it. If I just did this, then I have something cubed. Okay, see how that equals 27x to the 6th? And then this one is just y to the 3rd cubed. So now I've got my a and b that I can plug in to this little formula there. So finding a and b is just cube rooting this. I mean, all I did here was just take the cube root of 27 x to the 6, and the cube root of y to the 9th. And that's your A and B. Okay, anyone have an answer?
It's an absolute mess.
All right, what do you got?
Oh, I'm just substituting right now the.
Oh, okay. All right, let me know when you get it. And if you get it before I finish, then I'll give you like anyone is available to do that. Okay, so I'm just going to plug in 3x squared for A and y cubed for B. That's it. So I'm going to go, instead of A plus B, I'm going to say 3x squared plus y cubed. And then instead of A squared, I'm going to say 3x squared all squared minus AB. So you're just multiplying those two together, 3x squared and y cubed. So that's 3x squared y cubed. And then I'm squaring B. So B is y to the 3rd. I'm going to square that. And then I'm going to simplify this, clean it up. So this one's good. No parentheses, no variables that can be combined. So that's just 9x to the 4th minus this. There's no parentheses here, so I'm good there. This is just y to the 6th. Okay, I think it's easier to write it out like that, but you may find it easier to not do that and to just do it in your head. Okay, the hard thing to do in your head are these two things though. This is easy, you just squish them together, but first you have to know what the cube root of all that is. Okay, so it might be helpful to say, okay, A equals 3x squared, B equals y cubed. So A is the cube root of whatever that first term is, and B is the cube root of whatever the second term is. So now that you have your A and B, you can just plug it in. All I did was plug it in there, and then I cleaned up the parentheses. Did you get that before I did? Okay. So that was a slightly more complicated one. So let's try a difference of two cubes, which is just this. You're just plugging it into this instead of that. That's it. Okay. Let's try that. I'm gonna erase 2A here. Okay, we may have to jump to a free problem set on this one. Here's 2C. I'm tempted to say, give you a hint on the first step, but I don't know. I don't know if I should. Well, this doesn't look like anything cubic, right? How is that a difference of two cubes? Well, it isn't yet. I can't help myself. I have to give you a hint. But if I give you a hint, you lose the free problem set. You still get a flag attack. Should I give you a hint? You guys don't care. What's the first step of factoring? Do that first. Where's your hint? All right, I'm going to start, but I'm going to just go slow. If you get it before I do, then you get a flag attack. First step of factoring is take out a greatest common factor. 3 goes into both, and also m squared goes into both, and I'm left with m cubed minus 8. That's a difference of two cubes. Okay, so now I know that A equals m and B equals the cube root of 8. What's the cube root of 8? 2. Okay, so I'm going to plug in M for A and 2 for B. Here we go. I still have this lingering on the side, so I'm going to leave that over there because I still need it, part of my factorization. But now I'm going to replace my A's and B's with M's and 2's. So M minus 2, M squared plus 2M plus 4. You get it, Drew?
Not
Delaney?
but
Anyone else working?
I understand.
Okay, so the hardest part is just figuring out what the heck A and B are. And what you do, just plug it in. Just everything else is the same. The parentheses, the operation symbols, just put those in for A and B and put parentheses if you need to. Like I didn't need to in these because you were just squaring an M and multiplying M times 2. You don't need parentheses there, but it doesn't hurt. Okay. All right. So that is factoring the 2 cubic cubic polynomials that we know now. Now there's other ways to do that. We're going to learn later, but for now, just know that. So the next part is factoring by grouping. And actually we did something like this in Algebra 1. So make sure you write these down. Sum of 2 cubes and difference of 2 cubes. Okay, so we're going to factor by grouping. We're just going to start with an example. So factor by grouping. And usually when you have a problem like this, it's going to say factor by grouping. You don't have to guess on whether you do this or not. So basically, yeah.
Could you use the sum of 2 cubes to compare or difference of 2 cubes to compare the areas of the cube, or like an actual cube, not the
Like the areas of,
yeah.
well, I mean, if you're subtracting 2 cubes, then that's the difference of their area, or not their areas, but their volumes. Is that what you're talking about?
Yeah, that's what
Okay. All right, so here's a polynomial with degree of 3, which means we don't know how to do that yet, unless it's a sum or difference of 2 cubes, right? Plus 3x plus 15. Okay, now, hopefully, when you get to something like this, you're like, oh, there's got to be a greatest common factor I can take out. That's the only way to factor this. Well, there's not, because the x's stop there, so you can't take an x out. You can't take a 3 or a 5 out because this doesn't even have a coefficient, so you're in trouble. But here's what you can do. You can just factor a couple of these, and this only works when it says factor by grouping. But I can factor this. What goes into both of these?
X squared.
X squared. When I take an x squared out, what do I get? X plus 5, right?
Yeah.
Now watch this. This is magical. What can I take out of this? A 3. So now I can factor this. Now these 2 terms, really chubby terms, have a greatest common factor. They both have those in them, right? So now I can take that out. And what am I left with? I'm left with an x squared and a 3. That's satisfying. So you only have to do this when it says factor by grouping. So you don't have to guess and say, oh, I wonder if I can factor this by grouping. No, they're not going to give you, and they might in their homework, but on their tests and stuff, you never have to worry about that. Okay? So you could have done this maybe another way. Let's see here. Yeah, you could have put these 2 together. It doesn't matter. There's always a way to do it. So if I did this together, then I could take an x out of that. And then I get an x squared plus 3. And then I could have factored out these 2 together and take a 5 out of both of those. And then you get x squared plus 3. But look what happens. You can take an x squared plus 3 out of both of those and you're left with an x plus 5. Same thing. So it doesn't matter how you group it. You just got to be able to group a couple sets and then see if you get the same result when you factor those out. And you did. Okay, so that's factoring by grouping. All right, let's get crazy with that one. Let's do example 3C. Here's what 3C looks like. X to the 6th plus 3x to the 5th plus 2x to the 4th plus, where are you? I lost you. X squared plus 3x plus 2. Okay. So this is 6 different ones. So it'd be great if we can separate into 2 groups. Okay. So let's leave this alone because you can't there's not a greatest common factor there, but you can take a greatest common factor out of here. What goes into all 3 of these? X to the 4th. When you take that out, you're left with x squared plus 3x plus 2 plus another x squared plus 3x plus 2. So technically that's a 1 there, right? So when I factor out that big guy, x squared plus 3x plus 2, I'm left with an x to the 4th plus 1. Are you done? No, you can factor that. That's just x plus 1, x plus 2 times this guy, x to the 4th plus 1. So these kind of problems are fun because they're very satisfying. Like we cheated the system. It feels like we cheated the system. Like we can't factor that because there's no greatest common factor. Well, you can take the greatest common factor of a few of these and a few of these and then see if you get similar groups. Well, that's what we did. Okay. We are going to go into, we're going to learn more how to factor cubic polynomials and up a little bit later. But for now, make sure you know the sum and difference of 2 cubes. Okay. So if you forgot that or you didn't take notes, like half of you didn't, you can look in your book or you can watch the video to get that. Okay. And then make sure you know how to factor by grouping. All right, let's move on to lesson 62. All right, complex numbers. Complex numbers just have a real number and an imaginary number. So it's just the sum of a real number and imaginary number. Okay, so we talked about imaginary numbers, right?
Some.
Yeah. So it's just I. I is the square root of -1. You can't take the square root of a negative number, but the square root of -9 is not 3 or -3, right? Because it's got to be the same number times itself. But if you take out the square root of -1, then it's the square root of -1 times the square root of 9. Well, the square root of square root of -1 is there's only one imaginary number. It's I. And I equals the square root of -1. So the square root of -9 is just 3i. But we'll talk about that in a second. So a complex number is a combination of a real number and an imaginary number. So you could have like 5 plus I. Because the real and the imaginary don't mix. You can't combine those. They are definitely not like terms because one lives in reality and one doesn't. So you have to keep them separate. That's what we call a complex number. It's just a sum of 2 numbers, a real number and an imaginary number. Okay, so let's back up. I equals the square root of -1. That's the only imaginary number. So imaginary numbers aren't complex. Well, I guess they are. They're not confusing because there's only one. There's only one imaginary number, and that's the square root of -1. Okay, so if I did square root of -9, I could do what I normally do and break that into two radicals. So this is just something I can take the square root of is 9, and then have the square root of -1, right? Well, what's the square root of 9?
3.
And what's the square root of -1? I, so it's 3 times I. Okay, the easiest thing to do is just take that thing out of there and put an I. Okay, so if you see a negative in the radical, that's one easy step. Take it out and put an I outside of the radical. That's it.
I'm sure it doesn't get any more complicated in the future.
It really doesn't. I mean, when you square an I, what happens when you square I? What's I squared? Well, that's just the square root of -1 times the square root of -1. What's the square root of -1 times the square root of -1? What?
Is it just I?
What? Well,
What did you see was -1?
well, it's just -1.
Yeah.
Yeah.
So, you know what we did? We just made that. There's a totally nerdy math shirt that says "Get Real," and it just has I squared on it. Because basically we made that imaginary number real by multiplying it by itself. Because when you multiply a radical by itself, remember, it cancels a radical. You're just left with -1. So, okay, so that's the simplest way to explain it. So the square root of -25 is not 5, it's 5i. Okay? All right, so let's do some simplifying. Let's do example 1a. -2 radical -49. Okay, so -2 is already out there. You don't have to worry about -2. You just have to break up that radical. What's the square root of -49? Well, what's the square root of 49?
7.
So what's the square?
So -7.
So you just say 7i. So this guy is just 7i. Okay, so it's -2 times 7i. Now treat it like a variable. What is that?
-14.
That's it. Okay, so take the negative out, put an I, so your I is going to be in the answer. And then just take the square root of whatever's left in there, which is 49, which is a perfect square. So that's just 7. Okay? All right, what about this? Let's do example 1b. This is even easier, even though it looks more complicated. How do you simplify that? Well, it may not be easier. There is a sneaky 9 inside of there. So we can take the square root of 9. See, 9 goes in there 23 times. Okay. So what's the square root of 9?
3.
3. And then what's the square root of 23?
Square root of 23i.
And then square root of 23 space I, or pause when you say it, right? Because it's not the square root of 23i, it's the square root of 23i. Okay, so make sure that I is outside the radical. That's what we did. We just took that negative sign outside. We could have started like this and just said, okay, this is just the square root of 117i. But then 117 is a sneaky composite number because it has a 9 in it. So square root of 9 times the square root of 23. Okay, so 3 square root of 23i. Okay, so there's just one more step to simplifying radicals. If there's a negative in there, just bring it out as an I. Just like when there's a 9 in there, bring it out and turn it into a 3. But when there's a negative sign in there, bring it out and turn it into an I. Okay? So that's example 1. So example 2. Ew. we're going to solve this quadratic with imaginary numbers. So x squared plus 25 equals 0. Well, to solve this one, I would just move the 25 over and then square root both sides, right? X squared equals negative 25.
Yeah.
So x equals what?
25. Oh.
The square root of negative 25, right? And I put a positive and negative in there because that's what you do when you solve.
Oh, I thought that was like an I, a really messed up I. Okay.
So that's a positive,
Yeah.
negative symbol. And remember those?
I was
Okay.
like, what is that?
So what's this?
It's 5.
5i. That's right. So x equals positive or negative 5i, and you're done.
Yeah.
Okay. All right, and then check it. Make sure it works. Okay, so 5i squared is going to be negative 25 because I squared is negative 1. Okay, so that works. All right, so complex numbers. This all leads us to complex numbers is when you have a real number and an imaginary number occupying the same space. Okay, so instead of just 5i, it could be like 7 plus 5i or 7 minus 5i. Okay? Good way to remember that is you can't, I mean, they're like terms too, because variables, right? You can't combine 7 plus 5x, right? They have to be separate. Well, same thing with imaginary numbers. So, complex numbers is just a sum or difference, but we'll just say sum because the difference can be written as a sum of real and imaginary number. Okay? So you could have so a complex number is a number that can be written in the form of a plus bi. Okay? So see how there's a real number and then there's an imaginary part. Because an imaginary number is always written with an I after you simplify it. Okay, so now if a equals 0, I mean, you could have 2 plus 0i. Well, this is just a real number. Or you could have 0 plus 3i. This is just imaginary. But if you had 5 plus 7i, that is complex. Because technically, you can write any number like a complex number. If I wanted to say 2, I could say 2 plus 0i. That's a complex, 2 is a complex number, theoretically. Okay? But it would probably be like an improper complex number if you wanted to call it a complex number. So we basically have to say A can't be 0 or B can't be 0 if we want it to be a true complex number. I don't think we need to get into that. I mean, it's pretty self-explanatory. Okay, so when we want to add or subtract complex numbers, it's just like combining like terms. You can only add the reals with the reals and the imaginary with the imaginary. They don't mix. It's very dangerous to your health. So here's example 3a. Let's add these two together. 7 plus 4i plus negative 2 minus 5i. And if some of you are thinking, what's the catch? There's no catch. Just combine like terms. What's my final answer?
Can you foil it?
Well, you would FOIL if you were multiplying these together, but you're just adding. So when you add a parenthesis, you can ignore the parenthesis.
Okay. So
It's only when you're subtracting a parenthesis when you guys get into trouble
okay.
sometimes.
5 plus negative 5.
Yeah.
Yeah.
So these combine to a 5. These combine to a negative 1i or just negative I, or you could just say 5 minus I, same thing. Okay, so when you add complex numbers, just make sure you end up with two parts, a real part and an imaginary part. Sometimes the i's might cancel. If this was a 5i, then it would you just would have ended up with a 5. Okay. All right. I'm not going to do another example. Let's do this. Example 4 is of that non-example. This here's we're going to solve quadratic. So we're going to say x minus 3 squared equals -4. So x minus 3 parentheses squared equals -4. Okay. So how do I solve for x? What do I do?
Square the x minus 3. Could you do that?
Square root it.
You square root
That's
it,
what
yeah.
you meant to say, right?
Yeah, square root this.
So, and then whatever you do to one side, do to the other. Okay. All right. So what am I left with on the left side?
Square root of x minus 3 or x3 I. And you can't.
Yeah, it's just that square rooted, so it cancels.
So the two.
So you're just left with x minus
Oh,
3.
so you don't have to worry about I then.
Yeah. If it was just -3, then yeah.
Okay.
But it's not the square root of x minus 3.
Okay.
It's the square root of x minus 3 squared. So which is nice. Okay, so now what's this? 2i, that's right. 2, because the square root of 4 is 2. Square root of negative sign is I. Okay, now what? You haven't solved for x yet. What does x equal? Oops, sorry, I forgot the most important part.
Oh, 2i. Yeah.
So you get 3 on this side, right? If you bring that -3 over, it becomes a 3. Plus or minus 2i. That's it. Okay, I'm going to do one more example, and this is about as complicated as it's going to get for now. But we're going to solve x squared plus 8x plus 18. This is the whole purpose of some of this stuff. And we're going to solve this one. This is not factorable. This is not factorable, but we can solve by completing the square. Do we have steps for that yet? Yes. So we want to get our variables on one side and then our variables on one side and then constants on the other. Okay. So let's put our constant over here. Okay. So I get x squared plus 8x plus blank equals -18 plus blank. So now the critical step for completing the square is what constant do I add to that polynomial to make it a square trinomial? What's the formula? Do you know what we add to both sides? What makes it a square trinomial? Is if that constant term is the square of half of so you divide the middle term, the x term, by 2. So 8 divided by 2 is 4. And then you square it. So I'm going to add 16 to both sides. So because when I factor this now, it's going to be x plus 4 times x plus 4, right? Or in other words, x plus 4 squared. And then what am I left with over here? -2, right?
Yeah.
This is completing the square. This is why we use this stuff, is for this kind of problem. So we did this last week, I think, or 2 weeks ago, but completing the square. So get rid of the constants, put the constants over here so you have more room on your desk. And then your variables over here. So basically what you're going to add is half of that squared. Whatever number that is, divided by 2 and then squared. So 4 squared is 16. So now when you factor it, you're going to get the same thing times itself. In other words, x plus 4 squared. So now I can take the square root of both sides, right?
Mm-hmm.
And what am I left with?
X plus 4.
X plus 4 equals
Yeah, plus minus 2i. Or
Plus-
what was
Yeah,
Yeah,
plus or minus the square root
Square root
of -2,
So x equals 4.
-4,
Plus or minus 2.
square root of 2i. So the only thing you can take out of there is the negative sign. You can't take the square root of 2, so you have to leave that in there. So this is how you would write it. And this is most of the time when you see a complex number, it'll look like this. When we're solving quadratics, you'll have a radical and then an I next to it. So the only thing you can take out of that radical is that negative sign. So that becomes an I. You can't take anything else out of there. If this was -4, then yeah, it would be just a 2i, right? But it's not 4 like it was here. It's 2. So that's about as complicated as it's going to get. So it's completing the square with complex numbers. So a lot of times when you're solving quadratics, you'll have complex roots, which means you'll have complex solutions. And if you do, you'll have 2. It's always plus and minus that, whatever that is, okay? We'll do more of this later, but let your homework kind of give you some practice. And yeah, good.